Good morning, everyone. I'm making a video. We're going to continue with our notes. I know we haven't done much of our chemistry unit in a while, but at this point, I gave you a pretty lengthy project to do. Everyone should have handed this in by now. Some of you have not. Make sure that you get that project handed in as soon as possible. Um, but for everyone else, we're going to continue with our chemistry unit. Everyone should have gotten a a new packet for a unit that we would do after chemistry, but I want to finish our chemistry unit. So we're going to spend obviously a little bit more time on it than we usually would. And the assignments that we're going to do, we're going to go at a little bit of a slower pace because I know you guys have a lot on your plate. But that's kind of what the plan is going to be. So I think it's really important that you watch this video because I am going to post two things on Google Classroom, two assignments. One is very quick. It should take you no more than 5 minutes. The other one might take you a little bit more time. So these are the notes that I have right here. I'll be going through all the pages that you're going to need. These notes that I have filled out right now are actually notes that we filled out in class already. So I'm just going to go through the notes. I'm going to just explain a few things that I would like you to know. That's going to help us with our chemistry unit. Then I'm going to give you about a week or so to do the assignments. That way you can ask me questions, you can email me, post it in Google Classroom, and so forth. And I'm going to follow up with you guys to make sure that everything is okay. And that'll be our assignment for this week, and so forth. But please don't fall behind. I think I'm giving you plenty of time to complete these assignments. The element advertisement you've had a very long time on. So make sure you get these things in, especially because there's only three marking periods now. So I'm going to jump right into it. So in our notes here, we're talking about the periodic table. So I have the periodic table right here. We're going to go all the way to the 7th column. So right here, this is actually our transition metals. That's not our 7th column. But over here, this is going to be our 7th column. These are going to be our halogens. And that's what these right here. So the 7th column is called the halogens. And the last column is called the noble gases. Each horizontal row is called a period. And elements in a period are typically very different from each other. So let's kind of just go over a brief explanation of the halogens, the noble gases, and so forth. To reiterate some of the things that we did in class, I showed us a video of the alkali metals, and you remember the alkali metals were highly reactive, especially with water. We saw a video that all the different alkali metals in contact with water, and they reacted very heavily. Where the alkaline earth metals also reactive, but not as reactive. Transition metals, they're kind of in the middle. They're not super reactive. Some are, some aren't. Depends on what they react with. But then when we get to the halogens, they're typically not metals. They actually have. There's gases in this column. There's some solids. Fluorine and chlorine, for example, are gases. Bromine's actually a liquid, and an iodine and astatine are solids. But they're all very, very reactive. And then the last column, the noble gases, are not reactive at all. In fact, they don't chemically combine really with anything. So this is the column that contains helium, neon, which are probably gases you are familiar with. You've heard of them before, especially helium. Helium is not really reactive. So and that's true for all the noble gases. None of them are truly reactive. What we're going to go over right now is what the things in the periodic table really mean. There's, some periodic tables have a lot more information. The one in my classroom usually has pretty much these 4 pieces of information that I want to go over. The first and foremost of that number is what we call the atomic number, is this number 6. It's a very important number. It's the reason why the periodic table is ordered in the way it is. And it tells me how many protons and electrons are going to be in the nucleus of the atom. Well, the protons and the neutrons are in the nucleus. The electrons are actually on the outside of the nucleus, and they kind of orbit around the nucleus of the atom. You can kind of think of it like planets orbiting a star. It's not exactly like that. It is a little bit more complicated, but we can at this level, that's kind of how we can think about it. So if we look at our periodic table, that's literally what it means. And the really important number in this case is the protons. You cannot change that. So for instance, if we look at hydrogen, hydrogen is the simplest of the atoms. It has 1 proton in the nucleus. If you add a proton, that means you're changing the element, and you will actually change it into helium. And that's not an easy thing to do. However, this is actually what goes on in the sun every second. This is where the sun actually gets its energy. It's a nuclear reaction where hydrogens are fusing together. 1 proton or fusing with another proton, creating elements of 2 protons, and that's why the sun is made out of primarily hydrogen and helium. It's actually using up the hydrogen and turning it into helium. The electrons, though, they actually can flow around. Hydrogen can lose or gain electrons, and it won't change what it is. And that tells us on how it's going to react. But when we say the word atom, we are assuming that it is electrically neutral. So for the most part, the amount of protons and electrons in the atom are going to be exactly the same. But just know that electrons are free to kind of move around. Protons are not. And notice in this description that I have not mentioned anything about neutrons. We'll get to neutrons in a bit. The chemical symbol always starts with a capital letter, and some elements are going to have a capital letter and a lowercase letter as well. Never 2 capital letters in a row. So, when we use capital letters and lowercase letters, it does matter on how we are using them. And we've seen this before. I think we saw it with like carbon and oxygen. So for instance, capital C, lowercase o, that's the element cobalt. But if it were capital C, capital O, all of a sudden this changes. This isn't cobalt. This is now carbon and oxygen, and it's a compound. This is actually carbon monoxide. Very different, even though it's the same exact letters being used. So you got to really be careful about the capital letters and lowercase letters. And that's the chemical symbol, or the element symbol. The next is the element name. Pretty straightforward. Every element is obviously going to have a name. And the last one is the atomic mass. It's, in a sense, how much it weighs. And no surprise, if you add more protons and neutrons into it, the elements will get heavier. That's why in a periodic table, from left to right, they get heavier. Those numbers get bigger as you go from left to right. Hydrogen has an atomic mass of 1. Then helium has an atomic mass of 4. And most of this mass is coming directly from the protons and neutrons. The electrons really are not contributing to this mass because electrons are really, really small. They're very light. So most of this mass is coming from protons and neutrons. But if you kind of look at the pattern, they just keep increasing a little bit. There is some exceptions where the atomic mass actually goes down. This is one rare exception down here, element 52 and 53. Element 52 is actually 127, but then iodine actually goes down, and that has to do with the neutrons. Tellurium actually has more neutrons in it than iodine. But for the most part, as you go left to right, the atomic mass is going to increase. You're going to get heavier and heavier elements as you go from left to right, which makes sense. I mean, helium is very light. This is why we can put it in balloons and they're going to float, because helium, we can say, is lighter than air. I don't like using that terminology. You guys know that. It's less dense than air because the atom that makes up helium is very light. In fact, you could do the same thing with hydrogen, and this is actually something we would have done in the classroom. We would have made a hydrogen balloon, and it would have floated just like a helium balloon. But the big difference is hydrogen balloons can explode, and that is something we would have done. It would have been really cool. You see a balloon exploding. Definitely a little cool experiment that we would have done. But that is the atomic mass, and that is this blank right here. So now we're just going to get into some practice. And this is definitely going to be some of the most important piece of the video, because we're going to go do some examples. And those examples are going to directly translate to the assignments that I want you to complete. So right up here, what is the atomic number? So the atomic number is always this guy right here. So the atomic number is 2. And don't forget what that means. That means it has 2 protons and 2 electrons. And what is the element symbol? The element symbol is going to be He. That's the symbol. So it's not helium, because that's going to be the element name, which is going to be the last column. So the atomic mass is the decimal number. Typically, it is always a decimal. There are some elements in the periodic table that are not decimals. They're usually towards the end. And then the last thing is the element name, which is helium. So it's just practicing the main components from those boxes on the periodic table, that you know what each one means. The most important thing, I think everyone can kind of get a good grasp on the symbol and name, is knowing the difference between the numbers. That's kind of one of the big things. The atomic number, the amount of protons and electrons, is going to be hugely important. So in the second one, the atomic number is 17, which translates to it has 17 protons and 17 electrons. 17 protons, 17 electrons. That is what that number means. The element symbol is Cl. The atomic mass is 35.453. And the element name is chlorine. We'll do one more. The atomic number here is 26. Fe is iron. The element symbol, that's Fe. The atomic mass is 55.847. And the element name is iron. So some symbols are going to be completely different from their actual element name, and that's okay. So this is going to be one of the assignments that I have you complete, exactly like those 3 examples we just went over in class. So you can kind of see on how to do that. I think that's going to be very simple for most of you. Like I said, that's going to take you no more than 5 minutes. It's just practicing the different parts of that. The more challenging part of the assignment is going to be this page right here. So with this page right here, I'm going to do some for you. And again, you have this in your packet already. And if you don't, I'm going to put it on Google Classroom. You can, of course, just do it on a separate sheet of paper. So in this case, we're going to practice all the different components of it. And there's going to be one new part, which is number of neutrons. We're going to go over on how to calculate that number. So for the first one, the first 2 are actually all filled out for us. So I'm going to do the ones that aren't filled out, and then I'm going to do some more challenging ones, like all the way at the bottom, and see how they start giving you less and less information and how we're going to figure that out. So the first part just gives you the element symbol based on the name. You're going to get that directly from your periodic table. So having this close by is going to be very helpful. So in the first thing they said, it was hydrogen. So the element symbol is H. Its atomic number is 1. And that's where a lot of things are going to be filled out. So the atomic number is 1. And the amount of protons is also 1. And the amount of electrons is 1. Those 3 numbers that I just highlighted should always be the same. The amount of protons and electrons should be the same. And especially the amount of protons in the atomic number. Yes, I did say earlier that this number can change, but we are assuming that these are atoms, meaning they're electrically neutral. Even though that number can move around, electrons are free to move in an atom, we're going to assume that they're not going to move. But the amount of protons may not be the same. For some of them, they are. Like the one below in carbon, you see that there's 3 6s, amount of protons, neutrons, electrons, all 6. That may or may not be the case, but this is where the atomic mass is going to come into play. You're going to take the atomic mass, you're going to round it to the nearest whole number. So this number is 1. And then you are going to subtract the amount of protons. So you can literally take atomic mass, so I kind of put up, kind of rounded, minus number of protons. And that is going to equal number of neutrons. And that's why the number of neutrons in the first one is 0, because 1 minus 1 is 0. And that's exactly what we would see in the second one. They took the atomic number, 6. These are also 6. But then you take the atomic mass, and you minus the amount of protons, and that's where you get this 6 right here. So I'll do number 3. I'll do oxygen with you. So with oxygen, chemical symbol's O. Atomic number they gave you is 8. The atomic mass is 15.9994. Because the atomic number was 8, the number of protons has to be 8, and so does the amount of electrons. So how do we figure out the number of neutrons? We round our atomic mass, which this would round up to 16, and then we subtract 8. There, 16 minus 8 is going to be 8, and that's how we can figure out any missing parts in here. So what do we do with the ones that get a little bit more complicated? I'm going to go all the way to the last one because they give you almost no information. They just give you this 92. But if we go to our periodic table, well, it's 92 electrons. And we know, well, if it's got 92 electrons, that means it has 92 protons, meaning the atomic number is 92. So on our periodic table, we got to find where's element 92. It's down here. Element 92 is uranium. So we're going to fill that in. So we've discovered that this must be uranium, which is element symbol U. And the atomic number and number of protons and electrons are always the same. So these are also just 92. So I only got 2 blanks left. I got to go back to the periodic table and look up the atomic mass. And then the last thing I'm going to find is the number of neutrons. So I go back here, 238.03. 238.03. Rounded to the nearest whole number, that's 238. So to find the number of neutrons, we're going to take the atomic mass, 238, we're going to subtract 92. So I have a calculator right here, 238 minus 92, and I get 146. So the number of neutrons are not always going to be the same. So that the first 2 were done for you. I did oxygen for you. I did uranium for you. Your job is you're going to do the rest of these. If you run into any problems or you have any questions and you can't get it from rewatching the video, please put a comment in Google Classroom. Send me an email, whatever you need. I'm going to give you probably till the end of next week to complete these assignments, and then we're going to move forward in our chemistry unit. So expect more to be posted in Google Classroom because we had finished our project, and I wanted to make sure I gave you enough time on that project. But that's going to conclude this video.